Let's study the formation of sodium chloride, how this compound, this ionic compound is formed. You know the sodium atom, its electronic configuration is 2, 8, 1 because the atomic number of sodium is 11, right? That means in the nucleus of the sodium atom there are 11 proton, and so around it there are 11 electrons. And this electronic configuration, it means how the electrons are arranged in the different shells. You know, in an atom there are different shells known as K shell, L shell, M shell, and then N shell. The number of electrons that can be accommodated in particular shell are different. For example, in the K shell there can be a maximum of 2 electrons. In the L shell there can be a maximum of 8 electrons, M and so on. M is 18 and so on. So the electronic configuration of the sodium atom is 281. That means in the K shell there are 2 electrons, in the L shell there are 8 electrons, and the M shell there are 1 electron. So what happens is that sodium, when it loses 1 electron, that means the number of proton will be more than number of electron. Here in this case you'll find that there are 11 protons plus and only 10 electrons, right? But here in this case you'll find there are 11 protons plus 11 electrons. So 11 positive charge and 11 negative charges. Total charge is 0. But when it loses 1 electron, when sodium atom loses 1 electron, it has 11 protons and 10 electrons. So the net charge is how much? Plus 10 minus plus 11 minus 10 is minus 1, right? No, sorry, plus 1. So it carries a positive charge. So sodium atom, when it loses 1 electron, it carries a positive charge because the number of protons will be more than number of electrons. Earlier, the number of protons and electrons were same, 11 protons and 11 electrons. So the net charge was 0, there was no charge. But when it loses 1 electron, it carries a positive charge because the number of protons is 11, it remains same. The number of electrons get decreased, it gives out 1 electron. Which electron? The electron in the outermost shell. So it has a net positive 1 charge, that's why, and it becomes a cation, sodium cation. But what is very interesting is that the sodium cation is more stable than sodium atom. Sodium, when it loses 1 electron and becomes sodium cation, a positively charged ion, it becomes more stable. And the reason is that you see the noble gases, helium, neon, and argon, they are noble gases and they are present in group number 18. Their configuration is the helium is 2, neon is 2, 8, and argon is 2, 8, 8. And we find that these are noble gases. That means they are very noble. They do not react with any other element. They do not combine with any other element. That means they neither want to give away electrons or take electrons. While studying the electronic configuration, what we realize is that their outermost shells are 8, or that is completely filled. But the outermost shell is also called valence shell. Valence, VALENCE. The valence shells are filled. The K has the maximum, can accommodate maximum 2. The maximum, the K shell is filled. In case of neon, the L shell can accommodate maximum 8. So this one is also completely filled. The valence shell is the quota of the electrons of the valence shell is complete. Similarly, argon, it has 8 shells in the outermost 8 electrons in the outermost shell. So what we have observed is that if an atom has full quota of electrons in its valence shell, either 2 or 8, then it becomes stable. So this configuration, where there are 8 electrons in outermost shell, is known as octet. and the configuration of helium like atom is known as diet. So octet and diet electronic configuration are stable. So what we have learned here is that sodium atom, when it gives off one electron, it becomes stable because it has become octet. Its configuration has become octet. Its configuration is same as the configuration of neon. So it has attained the electronic configuration of neon, and that's why it has become as stable as neon. Similarly, on the other hand, when chlorine atom, whose atomic number is 17, right? The atomic number of chlorine is 17. That means its configuration is 287. Configuration means the number of electrons in chlorine atom. So it's 287. So out in the outermost shell or in the valence shell there are 7 electrons, right? So this is not a stable configuration. Had it been the configuration of argon, 288. So it lacks 1 electron in the outermost shell. So if it gets 1 electron in the outermost shell, its electronic configuration will be same as argon. So it will be as stable as argon, right? Or it will attain the octet. So chlorine atom, when it gets 1 electron in the outermost shell, the configuration becomes 288. And what about the charge? It will carry now negative charge. Because why? Because here the number of electrons and proton are same. 17 plus charge, 17 negative charge. 17 plus charge for the proton, 17 negative charge for the electron. So it carries no charge. It is neutral. But when 1 electron is added, the number of electrons this number of electrons will be more here. It will be 18, and number of proton will be 17. So because there's one electron is more, so it carries one negative charge more, so it becomes a negatively charged ion or chloride anion. Negatively charged ions or anions, and positively charged ions or cations. So chlorine becomes chloride ion, and its configuration becomes 288, and it becomes more stable. So we will combine these two processes in one and see how it is formed. What happens is sodium we will not write. See, what happens is that electrons are given out from the outermost electrons. The electrons in the valence shells are given out, or electrons are taken in the valence shell. So it's the electrons in the valence shell that is important, which determines the chemical properties of the element. So what we have, this is a way of depicting the formation of sodium chloride. So what we have done is that we have written the symbol of sodium Na, and we have just written one dot which represents the outermost number of electrons present in the outermost shell, 1 electron. What about chlorine? Chlorine has 7 electrons in the outermost shell. So we have denoted through using cross as 7 electrons of chlorine. 1, 2, 3, 4, 5, 6, 7. Why? The inner electrons are not depicted by dot and cross. We are only concerned about the number of electrons in the valence shell or the outermost shell. So in case of sodium is dot, and in the case of chlorine is cross. So what we can denote by dot only, but in order to differentiate that these are the electrons from sodium and these are the electrons from chlorine, we have used dot and cross. So this is the we are using dot and cross. We are going to explain how sodium chloride is formed. So what happened is sodium gives out 1 electron. So I've put an arrow so that sodium, after giving 1 electron, it has become sodium cation, and chlorine atom, after receiving 1 electron in the outermost shell, has become an anion. This is the extra electron which is received from the sodium, and it becomes anion, and this one has become cation. So since they are oppositely charged ions, right? And we know that oppositely charged ions attract one another. So sodium ion attracts the chloride ion, and there is a strong electrostatic force between the two, and this is how sodium chloride is formed. So one more thing is that this kind of compound where you find that sodium is a metal and the chlorine is a non-metal, and it's formed by ions, by attraction of ions, right? So these are called ionic compounds. So ionic compounds are formed when there is a metal and non-metal. Metals generally they wanted to give up the electrons, and on the other hand, the non-metals, they wanted to receive electrons, forming anions, and metals after giving up the electrons become cations. So Ionic compounds are formed only when there is a combination of metal and non-metal and forming cation and anions. You can see the electronic configuration of some metals, like say sodium 11 is 281 because there are 11 electrons. Potassium 2828. Okay, this is wrong. It should be 288, comma 1, right? So potassium is also one electron in the outermost shell. What about calcium? 2882. So it will give one electron and attain the electron configuration of argon, and calcium will give out two electrons in the outermost shell and will attain the stable electronic configuration of argon. What about non-metals? Say oxygen, as atomic number is 8, so there are 8 electrons, so configuration is 2,6. Outermost shell there are 6 electrons, so it will attain the electronic configuration of neon by just receiving 2 electrons, right? And it will become oxide ion. What about nitrogen? The atomic number is 7. There are 2,5. Instead of giving 5 electrons, they will receive 3 electrons and attain the electronic configuration of neon, a stable configuration. Similarly, fluoride, either they can lose 7 electrons and become the electronic configuration of helium, or you can get gain 1 electron and become the electronic configuration and attain the electronic configuration of neon. So it's better, instead of losing 7 electrons, they will just gain 1 electron and become an anion, and they will attain the stable electronic configuration of neon. So these are oxygen, nitrogen, fluorine. They are metals, and through their electronic configuration, what we understand is that they will always try to gain electrons and become negatively charged anions. And metals, they will always try to lose the outermost shell of electrons. To see, for example, this one, instead of gaining 7 electrons, they will lose 1 electron, right, and become octet. And then potassium also. In case of calcium, instead of gaining 6 electron, which will be more expensive in terms of energy, it's better to lose 2 electrons and become cation and attaining the octet electronic configuration of argon.